So yesterday we went over terms such as enlargement and reduction, and today we're going to focus on the scale factor and how that affects the original drawings. Let's keep in mind what we learned about enlargements and reductions. Your family recently had a family portrait taken. Your aunt asked you to take a picture of the portrait using your phone and send it to her. If the original portrait is 3 feet by 3 feet and the scale factor is 1 over 18, draw the scale drawing that could be the size of the portrait on your phone. So we're going to go back and annotate this problem. Remember to go sentence by sentence. So we know the original portrait is 3 feet by 3 feet, and the scale factor is 1 over 18. They want us to draw the scale drawing that would be the size of the portrait on our phone. Well, first of all, what is the shape of the portrait? So since it is 3 feet by 3 feet, we know this shape has the same measurements on each side, which makes it a square. So I'm going to go ahead and draw 3 feet by 3 feet and label it the original. And now the resulting picture, will it be a reduction or an enlargement if it would be the size of a portrait on our phone? Well, no phone is 3 feet by 3 feet, so we know it's going to be a lot smaller. So this scale drawing would be a lot smaller, therefore we call it a reduction. So let's go ahead and label it. To go from the original to the scale drawing, we are reducing it to fit on the size of the phone. So how do we know that? Well, we know because the phone is naturally smaller than a portrait that's 3 feet by 3 feet. And we can also tell because this scale factor is 1 over 18. And we're going to see more about why in just a second. So now that we know what to expect, let's go ahead and create our table with the information given to us about the original portrait. So I have the original. We're going to do something with the scale factor, and then we have new. So we know that the dimensions of the original are both 3 feet. Both sides are 3 feet. And then the scale factor is going to be multiplied to every dimension to get the new dimension. So why do we do this? Well, the scale factor is also known as the constant of proportionality, or way back when we called it the unit rate. And we know that we multiply every point by this number to keep our information proportional. So we're going to go ahead and do that here. So times 1 over 18 and times 1 over 18. In fact, let me get it set up correctly so that we can solve it correctly. And we really don't have to write it twice since we know it's going to be the same answer for both, but I'm just kind of trying to show a complete table. And so let's go ahead and review how we multiply fractions. We are going to go ahead and multiply it across. So we get 3 over 18, but I know that I can simplify that fraction by 3 on the top and the bottom. And so we end up with 1 over 6, and more specifically 1/6 of a foot. So that means we have the same thing here for this side. And so now that we have our new dimensions, we can go ahead and add this to our drawing. Okay, and so we just want to stamp that when we are finding new dimensions of a scale drawing, now that we have our answer, we multiply the original dimensions by the scale factor. So you're going to try one on your own.